All right, here we go. 2, 7. This is similar to the chain rule. We studied this a while back. Hopefully you still remember what that chain rule said. If A, therefore B, and if B, therefore C, big then, you can start at the beginning and end at the bottom, because these two B's, which end and start a conditional, can be collapsed. So we have A, therefore C. You may have also studied this in algebra class back there. It was called a property, not a theorem. I'll explain why it's a theorem in just a moment. But remember from algebra class, if A equals B and B equals 5, notice these are equalities and not those conditionals that we had in the chain rule. Yes? Then we know that A also must be 5. All right, so that was a property because of the equalities. In this theorem, which is going to deal not with equalities, but angles and segments. So I'm going to write it out here in terms of angles. If angle O is congruent to angle J, yes, and angle J is congruent to angle K, then we know that angle O is congruent to angle K. Okay? There was my bad joke for the lesson. This next rule, they actually call it a different rule, but you can give it the same name, and I'll just explain how it is a slight variation of this transitive theorem. Notice here we have AB congruent to NO segment, right? Segment CD congruent to PQ. So notice now we have two statements, and a third statement is going to come into play here. Now, if we know that angle or segment NO is congruent to segment PQ, notice those have already shown up, then we know that AB must be congruent to CD. Hopefully I didn't do that too fast. Yeah? So here's AB, here's CD, and NO and PQ, right? So notice we start with 3, end up with the first and the last. Does that make sense? And they all said yes. All right, so here's the little proof. Yay! I'm going to start with what we need to prove. So let me start there with red. So this line has to intersect FH in such a way that these two pieces here must be the same pieces. All right? Well, what do we know in the problem? We know, and let me change colors here, FG, KJ, right? And we know GH and KJ. Oh, I already marked that. Well, look at that. So if this angle is congruent, or that segment is congruent to that segment, and that segment is congruent to that segment, then these two must be the same, which means this point must be a midpoint, which means this line must be a bisector. Did that make sense? I hope it did. All right, I'm going to write that out now as a proof. So here we go. We know segment FG is congruent to KJ. And GH is also congruent to KJ. Aha, so they're both congruent to KJ. Therefore, we can say FG is congruent to GH. Yeah, and that is by the transitive theorem. So, notice if FG is congruent to GH, they both share that G, right? And we can see in the diagram, these are collinear points. Therefore, G is the midpoint. Just about repeated myself. Why? Because that's how we define a midpoint. And finally, if that is a midpoint, KG, the segment KG must bisect FH. And that is the definition of a bisector. A bisector has to cut a line at the midpoint. All right. A short little 4-line proof. Finally, the last thing important here, but very similar. It's like the transitive theory, but this is not a theory. This is a theorem. This is a property. Okay. So I'm going to illustrate it over here. First of all, notice I'm using equal signs and not congruent signs. So if I mess 1 equal to 57 and I have another mess, call it mess 2, equal to 57, why then we can say that mess 1 must be the same as mess 2. And by messes, these are like some sort of algebra expression, right? Because this is an equality. We're not talking segments and rays here, okay? So no segments or angles. You are only replacing values here. All right, and a short little proof. Here in the diagram, we are given angle 1 and 3 are the same. And I want to show that 3 plus 2 is 90. Okay, I know that 1 and 2 is 90. All right, well, if 1 and 2 are 90 and 1 and 3 are the same, then we can like replace 3 and put that in place of 2. And that's called a substitution. So again, our line 1, blah, 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 given, right? Won't waste your time with listing all that information out. But make sure that you have that. And some of you are forgetting to do the sketches on your diagrams. Please make sure you include those sketches on your diagram. Mark the sketches with the information that you're given as well. All right, line number 2. Well, if the two angles are congruent, then we know that the measures have to be the same. And that is the definition of congruence. Okay? And if the measures are the same, that means I can take the measure of angle 2, and instead of saying the measure of angle 1 like we did initially, and by the way, that was the book's error not to put an M there, I can replace it with the measure of angle 3. And that's exactly what we want to prove. So this was substituting. We took out the value of angle 1 and put in its place the value of angle 3. So this is substituting. You can certainly write the word property, but substituting is only a property, not a theorem. Hopefully that makes sense to you and will help you complete the 2-7